Okay, 12-2. Here we go. Clemson University Fact Book shows that 123 of the university's 338 were women. 76 to 63 associate professors and 73 of 375 full professors were women. What's the probability that a randomly selected chosen Clemson professor is a woman? So we just want the probability that you select a woman. Well, how many professors are we talking about? We're talking all professors. So that would be total. There are 338 plus 263 plus 375. That's a total number of professors. And how many of them are women? Well, there's 123, 76, and 73 are women. So we've got the number of women on the top, professors, and the total number of professors on the bottom. And so that's going to give me, got my calculator on the side here, 123 plus 76 plus 73 gives me 272 out of 338 divided by 263, or divided by plus 263 plus 375 gives me 976 total. So that's 272 divided by 976 gives me a 27.9, if I round it, percent chance of selecting a woman if I pick a professor at random. Okay, so that's probability that select a woman. B. What's a conditional probability that a randomly chosen professor is a woman given that it's a full professor? Probability of a woman given a full professor. So I'm going to write it like that. Now, I've got a formula I can use, or I can just think, given that it's a full professor, well, let's do it two ways. Let's just think this through, and then we'll use a formula and show you that they're really the same. Okay, full professor, so I know it's a full professor, so I'm only interested in the full professors. What's the probability that I select a woman knowing that it's a full professor? Well, I know it happens to be 73, so it's 73 out of 375. Okay, which is 375, 19.5%. Okay, well, we also had this formula that we talked about in class. Probability of A given B is a probability of A and B over the probability of B. Right? I'm only interested in the B's, which is what's given, and what's the probability of it being both A and B, as you'll see here in a second. So in this context, A is women, B is full professor. So probability of woman given full professor, probability of a woman and full professor, divided by probability of a full professor. So that's going to be, let's see, a woman. So we got to figure out what's the probability of if I randomly pick someone that they're a woman and a full professor, divided by the probability that I just pick a full professor. Okay, so we got to do a little bit of figuring out here. So if I pick somebody, let's do the denominator. What's the probability to pick somebody and they're a full professor? Well, that's 375 full professors, right? Out of 976 total. So 375 out of 976. And then the top is what's the probability to pick a woman and a full professor? Well, how many woman full professors are there? There's 73 of them. So that's 73 out of 976. And if I multiply top and bottom by 976, then those cancel. And I get 73 out of 375, which if you'll notice is exactly the same thing that we ended up here, right? Which is 19.5%. It's actually good that you can understand both ways. There's this formula which just explains mathematically what we did here practically. Okay? And C, are the rank and gender of Clemson professors independent? Okay, well, independent, remember, independent means the outcome of one doesn't affect the outcome, or knowing one or the outcome of one event doesn't affect the outcome of the other, as I started to say. So if they were in fact independent, excuse me, the probability of being a woman should be the same as probability of being a woman given they're a full professor. These should be the same if being a woman and a full professor are independent. Do we have that situation here? And the answer is no, we don't. These numbers are different, aren't they? They're not equal to each other. So in other words, somehow knowing that they're a full professor, the probability that they're a woman is lower than just being a woman. So somehow that's affecting whether or not you're a woman, of me picking that person. So there is some relationship going on, so they are not independent. Since these are not equal, let's do this. There is some relationship between full professorship and gender. Thus, they aren't independent. Okay, does that make sense? All right, just to recap, because if they were independent, if one didn't affect the other, then it wouldn't matter if I knew they were a full professor. These two probabilities would be the same. Okay, there you go.